Good morning to everybody and welcome to the first webinar of the NewWave project. I'm Giulio Poggiaroni from ETA Florence, and today I will be your host in this dive into the bioeconomy and specifically one value chain currently being developed by the NewWave partners. This one deals with modified wood, and we will get to know more about this thanks to our speaker today, Professor Anna Sandak, Deputy Director and Head of the Materials Department at Innorenew, which is a research institute based in Slovenia, having the goal of transferring scientific knowledge into industrial practice. So welcome, Anna, and thanks for being here with us today.
Hi, good morning, everyone. I'm super happy to be here and to share with you my presentation today.
Yes, before we start, I would like to say a few words about NewWave. So in the meantime that you share your presentation. So NewWave is a project funded by Horizon Europe, which is now 2 years old now with 2 more years ahead. And NewWave aims to transform existing fossil-based manufacturing lines into new bio-based ones, and developing chemical formulations that can be used to treat or realize new products. And these new products that we are considering in NewWave, developing in NewWave, must exhibit similar or better mechanical, physical, and chemical properties compared to the existing ones that we aim to substitute. And of course, they must be non-toxic and recyclable. So without further ado, I give the floor to Anna to guide us through the wood modification and the NewWave-born innovations. A few housekeeping rules. Remember to use the Q&A box to post your questions, which will be answered at the end of the presentations. So Anna, the floor is yours.
Okay, thank you, Giulio, for a nice introduction. I hope the topic will be attractive for you. I saw several people who are joining us, and then I'm presenting one of the manufacturing line in the NewWave project, wood modification. But I will also give you a bit of overview what is going on with the wood modification in general, and then where we are, and then just to position a bit our project. So when we talk about wood, I think here there is a lot of wood lovers who are joining this seminar. There is more than 60,000 different wood species, and I really like this periodical table of wood. It means then wood is so diverse, is so differently looking, but it also has different properties. And then wood can be applied for many different applications and has intrinsic properties, which are some of them are really nice, but some of them there is still room for improvement. But when we think about wood and as a building materials, it is very versatile, and it can be used for erecting different structures, from very rustic to the super modern. And I think this is a very unique material which gives such versatility for the outlook and for the properties. But when we think about the wood itself, it has some drawback, which is mainly because of some properties. And then, of course, as any material which is exposed to the service life in the use phase, it has some troubles with certain processes. And then here I prepare like simple table, which I try to explain different processes. And there are like some of them are abiotic, like weathering, waterlogging, but there are also some which are biotic. It depends on the biological agents, such as decay or insect degradation. And then we have also something which is more human dependent, like vandalism, but some processes which are really unpredictable, like earthquakes, for example. And then here I pointed some properties which are like physical and chemical processes which are occurring during this processes, but also properties which are affected. And then at the end, I summarize also some aspects which are very relevant for the service life as aesthetic, function, and safety. So you can see here there are some processes which are just affecting the aesthetics, for example, like weathering process. When we have the wood exposed to the outdoor condition, there is not much degradation regarding the function or safety issues, but the appearance, of course, change. But then we have also some processes which are much more severe and affecting all these properties. And then I'm talking about that because those are the properties which we would like to improve during the different modification processes. Okay, and then talking about the modification, I think the easiest is to divide the processes to active which are resulting the change of the chemical nature of material, in this case wood, and passive modification, which is mainly like filling the wood and then the lumen or the cell wall with some chemical agents. And then this sounds complicated, and this is even more because it's like the overview, which was adapted from the Dennis Jones, different processes, and then where we are here, and what are the commercial products already available, and so on. So you can see like there are several chemical processes, which are like, for example, acetylation, furfurilation, impregnation with some resin, some chemicals. Then we have the big group of processes which are thermally based. So here we have also like a influence of temperature, very often also with the influence of the hygroscope moisture, and sometimes also mechanical treatment. So in case of the densification, then we have some processes which are like combination of electromagnetic radiation, plasma, and laser. And then the other processes are like the biological treatment. It's like the big shift now to the enzymatic treatment, like some processes which are much more environmentally friendly, for example. Then here we have mineralization, biomimetics, and also some new processes. So here on the right, you can see like which of the processes are already commercialized. So some of them I will introduce you. But there is also something which is under development. And of course, there are several research lines which are like going on in different laboratories trying to substitute, as Julia was saying, this non-fossil fossil products to the bio-based. Then when we think about modification, I think Europe is really leading in the market. There are some treatments, of course, done in US, in Australia, but in case of Europe, we are very active. And then I will also show you a bit of overview of the wood modification conference, which was just 2 weeks ago in Florence. But nevertheless, those are the numbers, what is going on. And then as you can see, the biggest share is thermally modified wood, which is done by several different processes. So coming to the thermal modification, so it can be also divided to different groups. Some people say then charring of wood, like the surfaces, is also thermal treatment, is mild, but we usually talk about thermal modification when we are influencing material to the high temperature with the absence of oxygen. So then we have different processes here. And I have also like the samples with me. So this is like the normal Scots pine, and this is thermally modified pine. So you can see by naked eye, there is already some appearance changes, but it's not only the appearance which is changing. So thermal modification is usually like is one of the oldest process which is applied, and then of course is changing the color of the wood, but it's also changing the properties. As I was mentioning, on the bottom you can have here the veneers of poplar, which were treated with different temperature, and you can see, like you can guess, higher temperature related to the higher color change. But so there are some chemical changes occurring during the process, and then this is quite well understood. But I was mentioning there are several processes which are like dealing with that, and then of course they are influencing material properties in slightly different way. So we have the definition here on the wood modification. So it's exposing the material, the wood, to the temperature which is higher than 160 degrees with limited oxygen access. You can have the different atmosphere. You can have the steam or nitrogen atmosphere used, or hot oils. And then what is important, there are like several properties which are affected. And of course, those are depending on process variables. And these process variables could be different. Could be, for example, time of the duration of the treatment, can be also temperature, can be pressure. There are open and closed systems, so this is also affecting in different way. There is the present or absence of water, so it's also affecting. The different timber species are like responding indifferently to the same treatment. You have also adjust the treatment to the dimensions, and of course you can also use some catalysts, some additional chemicals joined. So these are also affecting the process itself. And then, as I was showing you the samples, this is just Scott pine, but when I was working in Italy, we did experiment with the water process, and then that was the process which was done at different temperature, from 160 to 220, and on different wood species. So we tested 8 different species, and you can see how diverse they were. And also we were like noticing then for certain species, we had some troubles. For example, there were cracks occurring much faster and so on. So wood was much more susceptible to the thermal degradation. So we have to adjust the process. So as what I wanted to say here is then the process is affecting the properties of different materials at various scale. So just to summarize the thermally modified wood, so is of course the wood is the most obvious is the changing of the color, which many people like, and then it looks like more like exotic wood and has opportunity to use the indoor. But what is important, that the dimensional stability is improved, and then so therefore wood can be used for various applications, and especially for cladding, for decking, it's like less shrinkage swelling. The biological durability is improved, but not with all agents. For example, with the termites, it's not really working well, but some fungi are less degrading these materials. And then, but there are also some drawbacks, like for example, the mechanical properties are slightly decreased, but this also depends on the treatment. There are some treatments which are decreasing them in only in slight way. So talking about different, like the overview of thermal modification in Europe, you can see like how different countries are making some treatments, and those were the data which were reported a few years ago by Dick Sandberg and Dennis Jones. Okay, and the second one.
Anna, sorry, may I ask you a question, just to curiosity that might be interesting for those who are listening to us. By using the thermal modification for which is, let's say, the durability of a wood product that is exposed, is used outdoor and is exposed to to the weather, what is generally the durability?
Well, it's improved comparing to the not treated wood, but I would say like it's used like the durability class 2 or 3, depending on the species you are using. So okay. It's not the optimal one, but it's much more improved, and especially if you are like using this for some species which are not durable at all. And so we had like the research regarding the poplar, which is considered as completely not durable, and then there was with the thermal modification, you were improving the performance. There was also a research line regarding the engineered wood products. So poplar veneers were used later for the plywood production, and that was like much more dimensionally stable and open up for new applications.
Okay, thank you.
Yeah, so going to the acetylation of wood. So this is like wood which is acetylated. So it's a bit like this is acetylated and it's not exposed outside, and that's I will show you later how it looks like. But this is the chemical treatment, which is a reaction of wood with acetic anhydride, and then we have the wood which is acetylated and acetic acid as a byproduct. And then I think you are familiar perhaps with Accoya, which is the main producer of the acetylated wood. They have also planned for the MDF, so it's acetylated fiber MDF productions, which is called trichoya. And then, so this is the wood, how it looks like. And then the most of the treatments are done with radiata pine, which is the most common for acetylation. But there were also some trials with alder and beech. So to utilize more species which are available on the market. And then coming to the properties, and then of course the moisture uptake is reduced, so you have less shrinkage swelling, which is relevant for outdoor application. So wood is more dimensional stable. So here we have really improvement of biological durability, because as Julia we were asking, so now we have the wood which is similar to class 1. So it is very durable, is resistant to the fungal attack, is also resistant to the termites, and then is also resistant to the marine borers. So you have very broad application portfolio for such wood. The wood has higher density and become harder, and there is no impact for mechanical strength. And you can see here on the right how the wood changed during the weathering, natural weathering, and of course it become gray. And then you can also see some molds which are growing on the surface. And so some customers doesn't like this outlook after time, but Accoya is doing great work with also with compatible coatings. I had privilege to test different coatings apply on Accoya, and that was like really nice combination. It's called like hybrid modification. So you are applying, you are merging different treatments together to achieve some performance. So you have very resistant substrate, and you have extra protection on the top of the material, and then it's performing really nicely. Then we have another process which is called furfurilation. So here we are using furfuryl alcohol, which is byproduct from the agricultural residuals or waste. And you are impregnated the wood with furfuryl alcohol and some catalyst. And then this is like mainly deposited in the lumens, but there are some theories then furfuryl alcohol can also be grafted, like the bonded with lignin. And so the furfurated wood looks like that, is also darker. And then it's slightly heavier than because of the impregnation, the fixation is quite good, it's not really leaching out. This is how it looks like. This is usually is done on radiata pine, but there are also some trials on the Scots pine. The Kebony is the company which is doing the furfuration on the biggest scale in Europe. And also regarding the properties, you have, again, the reduction of the moisture uptake. I'm mentioning moisture several times. It means then this is the property really to improve. So usually you have the lower equilibrium moisture content, so the wood is more hydrophobic and is more dimensional stable. Again, here is we have a really good improvement for the biological durability, class 1, so similar like Akoya. Then there is resistant to the termites, and then of course is weathered, and then you can see here on the right is become gray, but it's weathering uniformly, so it's become the color is grayish. But again, we can preserve this now is brown color when we apply appropriate coatings. The mechanical properties are improved, and then like we have like some release of acetic acid, like so it's like for the some connections, and so you have to really think about the fixation of such fixing of such materials. The same was valid for Akoya. Then we have the big portfolio of impregnation treatments, and then here this is one of what we are using also in the NewWave. So just in general, we can have the no pressure impregnation when we talk about the painting and sprays. So it's just the surface treatment. Then we have the diffusion treatment, which is like dipping the materials in some vessels. And then we can also improve the process by applying the pressure and so on. So going very briefly to these three different groups. So we have this first one, which is just surface. So you have the brushing or spraying, and this is not really like it's just surface coating, but it's still is improving properties, and especially when it's like the material is exposed. We are just talking about the surface. The penetration is minimal, but the coatings are like protecting against the UV radiation and heat and so on. Then we have the diffusion treatment. When you can see here on the movie, you are like dipping the materials in some liquids, and this is usually typically for waterborne preservatives such as boron salts and then so on. And then of course you are not using any pressure here, so this is not working well for all species depending on the penetration. Then finally, the third one with the most efficient is the pressure impregnation. So you have here variation of several different processes. There are different cycles, different conditions, and every producer, I think, is trying to optimize the process itself. So there is like some steps, which is like the vacuum impregnation and drying and curing. And you can imagine there are several processes in sequences. So all of them, they can be adjusted to see the certain, according to the results desired. And this is actually what we are trying to do now in the NewWave project. We had the bunch of the first modification done, and we were like, for example, we not observed then the leaching is problematic for some treatments, and we can work on the formulation to fix it better, but we can work on the process to adjust the properties and for example, to have it at the curing process at the higher temperature, and then we can have the better fixation of the formulation we are using. And then here we have I have also the samples. So it's like the wood can be soaked with different solutions, and then each of them is changing some properties, and then depending what you are using you have the outcome. And then just going as a summary, I think we were lucky to join the wood modification conference in Florence, which was just few weeks ago. And that was like a really big conference because it was 170 participants from 30 countries, 9 sessions, and then 50 presentations, the same number of posters. And there were like different sessions, like chemical and thermal modification, desiccation, mineralization, industrial session, which were dedicated to the certification and quality control, analysis, and nutrients. So I think was a really nice overview. If you are interested, you can check the proceedings, which is available online. But just to give you the overview for the trends, what I found interesting. So there was quite a long discussion for the quality control for well-established processes. As I was mentioning, there is not one mode of modification, so there are several of them. And then in order to have the quality, the certain quality assured, there are different methods to prove then the performance, and the process is according to the certain protocol, the wood is performing as we desire, and so on. Especially we are trying to adjust the existing processes for new samples, new wood species. This is really critical to have wood with certain properties. And then there is a lot of research with treatment of alternative wood species. We are now like facing the climate change. There is a lot of hardwood which is available, was not yet explored. So there is a lot of work related to the, for example, modification of beechwood and so on. Another topic very interesting is the hybrid modification I was mentioning before when I was talking about Akoya. So sometimes you can have something which is improving the bulk, the material itself, but then you can add on top some surface treatments. And those surface treatments doesn't have to be coatings, but can be also some plasma treatments and so on. So then you are improving the both bulk and surface, and you have material which is performing better in broader application fields. Then very relevant are the green processes. So we said we are going out from this fossil compounds, and then we try to develop green processes in terms of chemicals, also energy saving, and so on. So this is very much in line with the NewWave, which I will explain later, but this is it. Then there was like an interesting presentation about the alternative processes, entirely bio-based enzymatic treatments, biomimetic. I think this is really fascinating because nature knows a lot of solutions, and we just have to learn from it, understand how it is done, and we can perhaps copy this for the wood modification as well. And then was the last one was the new functionalities, which I was truly fascinated because there are impregnation of wood with phase-changing materials, the preparation of transparent wood with different protocols, and so on. So those are like the opening up for new application, and I think the wood, which is like really considered as the oldest building material, can have like very fancy functionalities and can be used for very like top applications. So that was really interesting. So then I hope I'm okay with the time. So going for the NewWave project, just to give you the overview, as Julio was saying, we have a project which is 4 years long. And then we are just in the middle, so after 2 years, and then so we have the coordinator BTG, from Netherlands. Hans was presenting the project a few weeks ago on the similar webinar. Then we have 11 partners from 6 countries, so it's like quite nice consortium. And the nice thing then, this is the project led by industrial companies, so it's like really like we are focusing on applicability of this developments, and then to have the really benefits for the future. So just to show you the overview of the project for those who are not joining the previous webinar. So we have the residual biomass and end-of-life products, and then we are applying process, which is fast pyrolysis process. And so it's thermochemical fractionation. And then we are producing fast pyrolysis bio-oils. And then we are trying to apply this, and then with some purification, some pre-treatment, but in case of wood modification, just straightforward for 4 manufacturing lines. So first is the furan-based chemicals, then there's the pillol and polyurethanes, engineered wood product, and modified wood. So I'm reporting the last one, the modified wood, but I'm pretty sure then Julia will organize also the overview from the other research manufacturing line. So this is what we do. We have the formulation, which were based on fast pyrolysis bio-oils. And then initially we had 19 of them. And then after initial screening, we used 10 of them for the wood modification. And then we were testing and trying to select the most optimal one. And also trying to see how the wood will perform in terms of durability, because one of our milestones was the wood, which is durability class 2. So this is the overview of the working package we were working. And as you can see, then we started from the TRL 4.5. So technology validated in the lab and validated in the relevant environment to the technology demonstrated in the relevant environment. So we will have the demonstration at the end of the project. We'll have the demonstration mock-up of all these materials which are developed by the NewWave. And let's hope then they will perform as good or even better than the fossil-based alternatives, which are now available on the market. So we had the 3 objectives of the project, and 2 of them are already like somehow checked, because we already are like having this 2 years of the ongoing work. So we first wanted to optimize the formulations and use them as a modification agent. So this is done. Then we were characterizing the properties with the multiple testing, and I will show you the first results of that. So we also checked this one, and then now we are in the moment when we recommended the best formulation, and our partner Foreco is preparing, the BTG is preparing the formulation. Foreco is using this formulation for treating radiata pine, Scots pine, and European beech. And then we will have another set of the work done, and then to select the best material. So this is how we started. The 10 formulations from 19 provided were used for the impregnation, the first modification. Then now we recommended 3, and then we are in the phase of performance testing. So we will be like exposing materials to different agents. So natural and artificial weathering, fire test, mechanical testing, screw withdrawal, machinability, and so on. And then the best formulation will be then used, upscaled and used for the demonstration site. So I'm reporting the first part because we are here, but I think we have nice results already. So just like how it was done, the BTG prepared this, in fact, 19 formulation, but 10 were selected because we were monitoring the parameters of this formulation. So we want to have something which is quite stable, has the constant pH, the viscosity which is desired, and so on. And then also there were like different changes in the formulation regarding some catalyst and so on. So we would like to have something which is working well, but not very complicated to do or expensive. Then we have the impregnation, the vacuum impregnation, which was then followed by drying and curing. And here I was mentioning then the curing can be further optimized, and we were also working on that. And on the right, you have the modified wood. And in fact, I have also here the samples, which are like this was radiata pine, which was used as initial, and this was one of the samples we tested. They smell like barbecue, so it's like for some could be advantageous, but we check also the VOX, and there are not really harmful substances going on. So it's like it's really a nice product. So you can see here the portfolio of different tests we performed. So the impregnation, the uptake of the liquid, density, moisture uptake, leaching test, dimensional stability, mechanical properties. In this time, we focus on the impact bending strength, UV stability, biological durability, VOC emission, wettability, appearance, and gloss and color as they are, but also after the irradiation. Hyperspectral imaging was used for the penetration, the screening of the penetration depth. Then we also check hygroscopic properties and thermal properties. So there was a lot of tests really ongoing. So we would like to have the overview of the properties, and this you can see here samples in action. So we really did a lot with them, and then we produced a lot of results. So this is like, I was thinking that it will be not digestible if we will go through all of this. But what we propose at the end, we try to summarize the most relevant properties for our application, and we had in mind cladding and decking in this case. And then we prepare a simple table, which is like that with the happy faces or not really happy faces. And then for us, it was like important to highlight the properties which are really important. For example, like if the agent, the formation are really fixed, they are not leached out. If the material is dimensionally stable, what is the contact angle, the behavior with the water, if, for example, it's hydrophilic, hydrophobic, if it's UV stable, if it's the durability class regarding the brown rot and white rot was very important, and also as with the mold. So here we had the one which was our winner, the treatment age. But we also suggested like to other formulation as just a trial with some slight modification of the curing process, and then we will be like now. I think in few months we will start another bunch of tests with a bigger scale of samples and just to continue the process, but now on the 3 selected materials. And beside of this performance testing, we were also doing the LCA. We started to do LCA and LCC and business feasibility. So we are here in touch with the Blue Synergy from Spain, and we prepare some initial information for the regarding the electricity use, heat use, emissions, and then also like all the steps for the modification, like the impregnation, drying, and curing, and also like the potential transportation and so on. So we are looking at the performance of material, but we are also looking at the life cycle assessment of these materials. So this is what I prepare. I hope I'm okay with the time, and we can handle also some questions if you have some.
Thank you, Anna. It was very clear. I would like to remind the attendees that they can post the questions in the Q&A box. In the meantime, I would like to ask you, since you anticipated that we will have a demonstration site within the NewWave project, which actually will be in Slovenia. So if you could anticipate to us something about the demonstration site.
Yes,
of course, information yes, which is publicly available.
Yeah. We are like discussing with our architects, and then we will prepare like some mock-up structure. And then here we have the ambition to present not only modified wood, but also all these products which are developed by NewWave. So we have to think well about something which will be, for example, be able to show the cladding as we are developing, but also the plywood, which is developed by Foreza, and MDF, which is developed by Foreza, and some use of the adhesives, which are developed by other partners. So then we will think about some mock-up structure, which will be demonstrating the performance. We plan to monitor the structure, so that we will have some sensors which will be monitoring the moisture and so on. But we would like to also make it attractive for eye, because we are hosting a lot of visitors here, and we will be hosting the final event of the NewWave, when perhaps will be some small conference here. So we would like to make it nice for eyes as well, just to promote the bio-based treatments to the public.
So yes, you will have the chance to see and visit the demo site, and of course, from the communication side, we will give plenty of coverage of this demonstration. There is one question. Could you please tell me more on the curing process? Was there a big difference on the mechanical properties of the final modified wood with or without curing done?
Okay, so in this at this stage, we did the curing was done for the all materials. So that was the curing process was performed by Foreco, and every products were cured. So and then of course we had the differences in the mechanical test. The one which we were selecting was the modification was affecting less the impact bending. For the moment, we checked just impact bending, because we were also thinking then perhaps this property is like relevant also when we consider the utility poles and other applications. So all of the material which were modified has lower impact bending, so it means it was weaker to the mechanical properties were decreased. But the one I have to have a look at the table if I would like to provide the certain value. But we did the curing was present in every treatment for the moment. Yeah. But we were like thinking to adjust the curing mainly for improving of the biological durability. That was our concern, because if we think about the cladding material, the mechanical properties are not that relevant as durability, and especially regarding the brown rot and white rot. And so the curing was adjusted to focus on the durability class 2. So that was our main, and that was one of our milestones here in this project.
Okay, thank you very much. The attendees thanks you for the reply. Maybe I have one comment or reflection, which is more due to the sourcing of the raw materials that we are considering here, because of course we mentioned that to produce the pyrolysis oil that is at the base of the NewWave processes, we use biomass residues. Do you see a challenge in the collection and or the sourcing of this biomass? Because we know that in Europe we have a lot of biomass residues which are unused, but still we are struggling to collect all this biomass. Do you think this is a major challenge, or you are more optimistic about this?
I think we were like really thinking well in the NewWave project, because from each of the manufacturing line, for example, the modified wood at the end of life will be again chipped and coming back to the process. So we will be making also the fast pyrolysis oils from our products, just to show demonstrate the full closing of the circle. And this will be also done with the MDF, with the plywood from the another products developed by NewWave. So besides of relying on the biomass, which can be variable, but we are using here residuals, which are like then usually accessible. But we are also feeding our system with end-of-life products from the processes. So we will try to demonstrate then also the waste from the building sector and the end-of-life products could be also turned by this process to the valuable chemical components, which can be then closing the loop and used again for the impregnation and so on.
Yeah, so it's going to be a fully circular process, and with the engagement of the industry sector, but also the construction sector, which will be an element which will secure this potential criticality on the sourcing of the raw materials. We have another question. You mentioned that modified wood had gun termite resistance. Is this due to toxicity of the modified wood, or due to increased density, or some other mechanism?
Yeah, this is like I had chance to test for example, acetylated wood, all the modification processes in FCBA with Dr. Magdalena Kutnik, and we were working with termites, and this was the process I was observing by ourselves. And then, in fact, there is a lot of research going on, and there is like not really clear like what are the mechanisms and why they don't like. But yes, for example, acetylated wood was not really consumed by termites. And we think then the termites cannot recognize the enzymatic profile of termites cannot recognize and they digest the wood itself, which is modified, and because it's the acetic anhydride is bonded. So we think it's not digestible, but of course it's also denser. But when we have this choice test of not treated and treated, and then so thermally treated wood was always eaten and was not problem for termites, but acetylated and furfurated was not touched. So that was three treatments which were working well. Most likely the termites cannot digest it. But I'm not expert in the insects, but we were wondering that this is perhaps the mechanism of avoiding.
Okay, thank you very much. So if the attendees have more questions, this is the time to post them. In the meantime, I would like to remind that in the chat we have posted the links to the NewWave website where you can get to know more about the project, and also the link to the download section when you can deep dive into the manufacturing lines with our project fact sheets. I can also anticipate that NewWave will organize an event at the next European Biomass Conference and Exhibition in Marseille this June, with other 5 projects financed in the same Horizon call. So this will be the chance to compare similar ideas and similar value chains being developed in Europe and promoted and financed by Horizon Europe. This will be very interesting, especially for the fact that this project have high density of industrial partners, let's say, more compared to other more research-oriented projects. So don't miss this chance. I see no other questions coming up. So just to remind that this recording will be soon available on the NewWave website. the presentation will be available too on the website. And in the meantime, I can thank Anna for your presentation and for your availability today. Thank you for the attendees, and see you in the next webinar of the NewWave project, which will tackle another manufacturing lines out of the 4 that we are developing. Thank you, Anna, again, and thank you to all the attendees. Have a nice day.